In chapter 6, exercises for chapter 6, we're starting with multiple choice questions. A campus program enrolls half undergrad and half graduate students. If a random sample of 4 students is selected from the program to be interviewed about a new fast food outlet on the ground floor of the campus building, what is the probability that all 4 students selected are undergraduate students? So we have n equal to 4, we have p equal to 0.5, since half are undergrad and half are graduate students. That means we have binomial probability distribution. We want to know what is the probability that x will be equal to 4, all 4 students. So n times p times x, n will be equal to 4, p is 0.5, x is equal to 4. If we were to use our graphing calculator, second VARS, binomial PDF, we will do 4, 0.5, 4, close parenthesis, and enter. The answer will be 0.0625. So the correct answer will be B. Which of the following about the binomial distribution is not a true statement? The correct answer in this case would be D. The random variable of interest is continuous. That is not correct. It is discrete. A continuous random variable may assume any value in an interval or collection of intervals. A company has 125 personal computers. The probability that any one of them will require repair on a given day is 0.025. To find the probability that exactly 20 of the computers will require repair on a given day, one will use what type of probability distribution? This would be binomial with n equal to 125, p equal to 0.025, and in this case, x would be equal to 20. So the correct answer is A. Which of the following is a required condition for a discrete probability function? This would be D. The sum of the probabilities has to equal to 1. Now, for the problems, a certain type of new business succeeds 60% of the time. Suppose that 3 such businesses open where they do not compete with each other, so it is reasonable to believe that their relative successes would be independent. What is the probability that all 3 businesses will succeed? So we have P equal to 0.6, we have N equal to 3, and we want to find the probability of X to be equal to 3. I always have in the solutions how to use the formula in case you feel more comfortable using the formula. But I will show you the graphing calculator because it's a lot faster. If we're using the graphing calculator, we're going to go to second VARS binomial PDF, and we're going to do binomial n, which is 3, comma p, 0.6, comma 3. Second VARS, binomial PDF, 3, comma, 0.6, comma, 3, close parenthesis, enter. 0.216 for the answer. 0.216. What is the probability that at least one business will succeed? At least one is x greater or equal to 1. We cannot calculate it this way. We have to rewrite it. At least 1, including 1. We have x equals to 1, 2, 3. We stop at 3 because this is our sample size. We can only go up to our sample size. So in this case, we will, if we were to use our graphing calculator, we would do binomial PDF of 3, 0.6, 1 plus binomial PDF 3, 0.6, 2 plus binomial PDF 3, 0.6, 3. If you do your calculations using your graphing calculator, you will have 0.936. 0.936. For binomial, it's really, really important to pay attention to keywords. At least, less than, more than, exactly, equal to. Need to be very, very comfortable with the signs. For problem number 2, 40% of all registered voters in a national election are female. A random sample of 5 voters is selected. Find the probability that the sample contains 2 female voters. So we have n equals to 5, p equals to 0.4, and I'm looking for the probability of x to be equal to 2, exactly 2. So we will do binomial PDF n, comma, p, comma, x. So, second vars, binomial PDF, 5, 0.4, 2, close parentheses, enter, 0.3456. So this will be 0.3456. If we were to round up to 3 decimals, this would be 0.346. Find the probability that there are more than, keyword, more than 3 females in the sample. More than 3 means you do not include 3, so you're calculating the probability of x to be equal to 4 plus the probability of x to be equal to 5. So we will do binomial 5, 0.4, 4 plus binomial PDF 5, 0.4, 5. So this will be 0.087, again rounded to the 3rd decimal. If I'm looking for the expected value of the binomial probability distribution, n times p, simply 5 times 0.4, so this will be equal to 2. The variance, this would be 5 times 0.4 times 1 minus 0.4, 0.6, so this will be equal to 1.2, and the square root of 1.2 for the standard deviation would be 1.095. Now, let's take a look at the next problem. This table contains the probability distribution for the number of retransmissions necessary to successfully transmit a 1024K data package through a double satellite media. So we have the possible outcomes with their corresponding probabilities. And I'm looking for the expected value for the number of retransmissions. That means I'm looking for the average. I'm also looking for the variance and the standard deviation. So, starting off with the expected value, we create our table. We have x and we have the corresponding p of x. All I need to do is take the product of the 2 columns and at the end add them to find the expected value. So 0 times 0.35, 0, 1 times 0.35, 0.35, 2 times 0.25 is 0.5, 3 times 0.05 is 0.15. So I add them all, and in this case, the expected value happens to be 1. So this will be 1. Now, for the variance, I fill out the column with x minus mu squared times p of x for each outcome. You will take each outcome, you will subtract the expected value, you will square whatever you find to get rid of the negatives, and then you will multiply it with its corresponding probability. So this will be 0.35, this will be 0, this will be 0.25, and this will be 0.20. So if we add them all, this will give us the variance. The variance in this case is 0.80. 0.80. Now, the standard deviation, as always, the square root of 0.8. So this will be 0.895 for the standard deviation. Variance is 0.8, expected value is 1. Excuse me. Next, problem number 4. AMR is a computer consulting firm. The number of new clients that they have obtained each month has ranged from 0 to 6. The number of new clients has the probability distribution that is shown below. So you have your X and you have your P of X, basically. First off, we want to find the expected value. We will find the expected value by calculating X times P of X for each outcome, and at the end, we will add them. So 0 times 0.05, 0. 1 times 0.1, 0.1. 2 times 0.4, 0.2 is 0.4. 3 times 0.3 is 0.9. 4 times 0.2 is 0.8. 5 times 0.1, 0.5. 6 times 0.05, 0.3. We add them, and this will give us the average. The average in this case is 3. Now, you take the average, and again, always make sure that your calculations for your average, your expected value are correct, because you will be using it for the variance and the standard deviation. You will do 0 minus, for each outcome, you will subtract the expected value, square it, and then calculate it with the corresponding probability. So for the first one, this will be 0.45, 0.40, 0.2, 0, 0.2, 0.4, 0.45. Now at the end, we add them, and this will be 2.1. So your variance will be 2.1. Therefore, the standard deviation, the square root of your variance, which will be 1.449. And this concludes the exercises for chapter